I'm Joe, KA4WJB. I have a direction finding antenna. This is a 2-meter antenna with 2 quarter wave verticals, 1 quarter wave apart, and has a sharp null pattern that I marked here. I look for a null in the direction finding, and as you swing it around, you have a sharp null when you're looking for it. These are ground planes, quarter wave ground planes. I made them out of tape measure and PVC tubing, and I made them so when it'll fold up in the heat of battle, jumping out of a vehicle. But I've also made them out of stripped wood and coat hanger. There it is.
How much did it cost, Joe?
Just a few bucks. It's the price of a tape measure, it's a pipe, and a little bit of coax in between.
Very good. All right, thank you. Ready.
Okay. All right, this is David Rocky, M4WQF, and this is a TDOA antenna that I built. I got the board from Far Circuits, and the parts are just standard parts you can buy at any parts store. The idea of this antenna is to measure the time in which the signal reaches each antenna, and when it reaches them at the exact same time, it'll be quiet on your radio. If it's slightly off, if you turn it, you'll start to get a tone one way or the other, which will let you know that you're not aiming toward the antenna. Now the downside to this antenna is that you really can't, there's one thing you can't determine, is it forward from you or is it behind you? So you have to use some directional techniques of finding that in order to resolve the problems with this antenna. But as far as getting a pinpoint direction, these antennas are very accurate.
And how much did it cost?
The cost was about maybe $15.
Very good.
$7 for the board, and then just little parts.
How long did it take you to put it together? 3 weeks?
No. If I did it all at one time, it would probably take about 3 to 4 hours.
And if it doesn't say Binford on it, somebody else makes it.
David Rocky, N4WQF again. Now we have a Yagi antenna we use for fox hunting. This could be built real cheaply.
I don't think so, Tim.
It's made out of tape measures, and the nice thing about the tape measures is when you're fox hunting, you can always, you know, if you hit something, these will bounce right back. I mean, it's probably a very durable type antenna. You can carry along extra radials if you need to. PVC pipe for the center. The total cost of this thing, again, might be about $15 and a couple of hours to put it together. Very directional, nice for hunting. You can turn it the way you want to and find the direction of the fox and then head in that direction. Another good thing with this is when you get a heading on it, if you have a compass, you can have a compass here and you get a heading and then map it and draw lines on a map and triangulate location in order to find out where the fox is. This does work very well for transmitting as well as receiving. If you need a good portable Yagi antenna for, you know, low watt usage but very good distance, this is a good antenna to use. Like I say, there's very little to it other than a PVC, tape measure, some coax cable, and some hose clamps, and that's about it. Now there's another one you can use that's very similar to this. It's a 2-element version of the same thing. Lighter in weight, does the same thing. The gain is not quite so good. Costs a little bit less than the 3-element, of course. But bottom line is very functional for both fox hunting and using your antenna for transmitting if you want to. If you need a distance away from a repeater and you need to point toward the repeater, good antenna to use.
Very good. Thank you, Dave.
Hello guys, I'm KB4FUZ, Robert. We have different types of attenuators that we use for our radio direction finding. Small types like this, which this can be had from far circuits. It's an ARRL project. It takes a couple hours to build. Very inexpensive, probably $10, $15 worth of parts. Or you can use other types that you can find surplus. I picked this up. It's got 80 dB of attenuation, but it was very inexpensive at a Hamfest. We have any type of handheld.
I'm not only the HECMA president, I'm also a client.
What is very important is finding ways to secure your handhelds so that you don't drop them, because it becomes very cumbersome sometimes when you're operating. So you can get a simple lanyard, hold it, you're holding your antenna, possibly some type of belt clip for your attenuator so you can hands-free operation. Also, UHF or dual band handhelds are very helpful in the sense that you can use the third harmonic of the original frequency to give you a much more desirable attenuation.
I'll have a hamburger, for which I will gladly pay you Tuesday. Very good. Thanks, Robert.
Okay, we've got a small little fox in the tree that's right there, right here in the parking lot.
Okay, point source confirmed. Whatever it is, it ain't local.
Fire array in producing a null. What do you see right now, Joe?
I see on the high end, I see 4 bars. Swing around to the null. Practically nothing on the S meter.
So I don't see any signal there. Okay, now I see signal. Okay, I see 4 bars, it looks like, 5 bars, and you null it out, and you're pointing right at it. Okay, that is the end-fire array. Very good. Thanks, Joe.
Sure.
Alright, I've got David here now, going to show the 2-element Yagi, and we still have the fox planted in that tree right there. It's a little miniature transmitter, and he's using a step attenuator, and you can see the signal strength on his radio here. I'm going to try to zoom in just a little bit. Can you see that? Okay, so he's got some signal. Go ahead and put some null into it there, Dave, or attenuation into it. Okay, he's pretty much took it all out now. See how that signal came back? Oops, sorry. See how that signal came back there? Very good. Now move that antenna to the side just a little bit. Okay, and back to it. The signal gets stronger there. And weaker there. Very good. Alright, that's a step attenuator. Thanks, Dave. Okay, Ken, KJ4CTZ here again, and I've got a little 4 megahertz offset attenuator that's right here that Joe's going to demonstrate with his end-fire array. You see how close he is right there to the actual Fox transmitter, and right now he is on the high gain side. Can you see the no, stay on the high gain side there, Joe, and let's see the signal strength here. I think you should be able to see that. It's full strength. And now go ahead and turn that antenna around there slowly, Joe, and let's see if we can see the signal strength in the antenna at the same time, and it pretty much just nulls right out. This is the benefit of an offset attenuator, where no RF can get into the radio. It's actually shifted by 4 megahertz into the radio so that you can really adjust it with a pot right here, a linear taper pot for great nulling. Man, that's awesome. All right, thanks, Joe.